Hi there, this is Theodore, and today we're going to write some code in order to feed data in our pipeline. From now on, we're going to replicate the Chicago text pipeline example from the tfx repository. The task is relatively simple. Given some trip data, predict if the customer is a big tipper. Such models are used to prioritize driver to passenger matching if taxi demand is high, for example. For the seasoned TensorFlow developers, we're going to focus on the newer keras with the TensorFlow version 2 API and provide no focus on the old estimator API whatsoever. Let's get started. First, why does this component exist? Well, we have to start our pipeline somewhere. This is usually the first step that connects the tfx pipeline to another external system. The ExampleGen component ingests some kind of data feed and produces tfrecord files as output artifacts. These input data samples usually come in a train and validation split. For example, you can read a pattern of CSV files under a directory, which is what we're going to use for simplicity. Alternatively, you can read data from raw files, BigQuery, or even connect to Kafka or a lot of other systems. There are connectors for almost everything. There is also a significant amount of configuration regarding train and validation splits, how many files or hash buckets to use for the output splits, or on what column to split output files on to produce the shards. This configuration is in the protocol buffer format, with native Python code generated stubs. What are these tfrecords files actually? They are serialized tf.example instances, and a tf.example is a specific protocol buffer format. The schema is key value, with the key being a string and the value being a single entry or list of ints, floats, booleans, enums, or strings, basically any data type. There is also some metadata about the length of the payload and a CRC hash used for integrity checking. Explaining protocol buffers is out of the scope of this series. You're encouraged to take some time to understand how they work and read about them. As far as tfx and TensorFlow go, tfrecords are used for their serialization capabilities. We need a standardized high-speed and zero overhead format to pass data around. This also comes in handy while building models from feature columns and when feeding data into TPUs. Datasets are usually being parsed to multiple small tfrecord files to the 1 to 100 megabytes range. This helps to keep up with the huge number crunching speeds of TPU clusters by reading many data samples parallel from multiple tfrecord files that exist in a distributed file system like the Hadoop file system or the Google file system. Other protocol buffer definitions exist under the tfx.proto namespace. I encourage you to take a look at their structure. Also note that tfrecords interoperate perfectly with the tf.data.dataset module, which we're going to use when feeding data into the model as part of the training process. Since this is the first component of the pipeline, we are going through the small overhead of setting up the pipeline as well. First, make sure that your local Python version is supported by tfx. I encountered a lot of errors when running this on Windows, so if you're using Windows and get strange errors for no reason, run this through the Windows subsystem for Linux. Then install the tfx package through pip. All the necessary libraries, including Beam and TensorFlow, will be downloaded and installed automatically. From now on, you can either reproduce the code you see in this video or clone the repository from GitHub at the link in the description of the video. We're going to download the taxi data CSV and place it into the data directory right here. If you clone the GitHub repository, you can skip this step. Then create a Python file named pipeline.py and let's get started. First, we're going to specify some key required parameters for the pipeline to work and be configurable. These are the pipeline name, the MLMD file location, which we're going to just use file-based SQLite instance, data location, and artifact output root directory. Then just add the simple CSV ExampleGen components with the data path as an external input and wire everything together inside this parameterized function. Finally, you can run the pipeline via the local Beam.deck runner. You can specify native parameters here, like multiprocessing. If you want to run this on the cloud instead of locally, you can use a different runner like the Kubeflow runner. We're going to showcase this later in the series. Now, let's give it a try. Just run it as you would run any Python module. In this case, we will just use the straightforward and classic way, running it through the console. You can see that each component logs its execution on the CSV example generation component in this case, and the artifacts are the tfrecords as expected. Note that the tfrecords are also gzipped to save space. The provided data path contains a single CSV file. By default and per best practices, tfx automatically extracts some validation split. This is fine-tunable, but the automatic split is okay for now. All the code is available on GitHub with the URL available in the video description. In the next video, we're going to examine the raw data to check if they're good enough for preprocessing and model training. Thanks for watching and see you in the next one.